Hi, I'm Erwin, Director of BG Proving Ground, and welcome to our engine case study. Been with BG products for 30 plus years and fully involved with our research and development from our tools and equipment all the way into our service programs. We're going to take a junkyard engine and perform some BG services on it and find out really what our results are and what are we looking at.
My name is Paul Garcia. I'm the BG Proving Ground Shop Manager. A little bit history about myself is 8 years as a Volkswagen Master Tech, 4 years as an Audi Master Tech. I am also ASC Master Certified, and I've been with BG for 5 years. And we're going to take a look in today and see if we can restore a junkyard engine and see what kind of results we can get out of that. And feel free to like and comment and ask any questions about any of the process procedures we're going to talk about in this following video.
Okay, so let's talk about what engine we selected. So we chose a GM 2014 5.3 liter GDI engine with 114,000 miles on it. So what our goal here is we're going to take this engine, we're going to set a baseline of what it is, and we're going to come back and we're going to perform 2 of our BG services on it, and then we're going to take it all apart, check it out, and see what the results are from a before and after standpoint. So the 2 services that we chose for BG is our Platinum Fuel System Service and our Engine Performance Service. So we'll get more into that here in a minute. So let's talk a little bit more about the Proving Ground. So Paul, what can you tell us about the Proving Ground?
Yeah, Jay, the Proving Ground is going to consist of 3 different teams within the Proving Ground. So we're going to have, of course, my team for the shop and doing all the dyno testing and any of the on-car testing. Then we'll have the technical service team as well, which answers all the phone calls out to the field. And we actually have, and they also do actually adapters testing, working with our whole engineering department. So really we have 3 teams built within the Proving Ground. And with that, like far as the facility goes, we have 9 full service bays, which 4 of them directed for BGU, and also our technical service team actually uses those to not only teach, but also to bring in cars for vehicles that get new adapters and stuff that they see in the field. On my side, I have the 5 service bays, and we actually do a lot of the on-car testing, the new products, competitor products. When we're designing the tools, we go all into that and try to see what we can do. And along with all that, just to top it off, we do have 3 different dyno systems. So the 3 dyno systems we have are all made by Superflow. So we have the ATV side-by-side motorcycle dyno. We have the all-wheel drive chassis dyno with the big rollers on the back, so we can do dualies. So we've done anything from a F450 all the way down to a Prius. And then to top it off, like on this case study, we have our Superflow black window engine dyno. And yeah, let's get into it.
All right, so now let's talk about what we're going to test. So we're going to test compression. We're going to test emissions. We're going to find out the horsepower and the torque. We're also going to check the crankcase pressure. And lastly, we're going to check our fuel consumption. So Paul, tell us what we're going to use to measure fuel consumption.
Yeah, Jay, we use the tool called the AVL Plutron. So the AVL Plutron will measure the fuel flow. It's usually mass fuel rate, so it's going to measure the fuel flow. So it's exact fuel consumption. And before I get into this, how it does that, AVL is a world leader as far as R&D equipment. So they provide us R&D solutions for different industries around the world. So a lot of OEMs use them. So how it measures the exact fuel consumption is on the positive displacement principle. So it's a flow meter, so it's going to measure what the fuel is coming in and not the fuel coming out. This is a returnless system, obviously, but it can measure that down to hundreds, thousandths of a gram of fuel flow. So that's what we measure as far as fuel consumption goes.
So now we're going to take our engine and completely tear it down. We've got our baseline set, and we're going to pull all the components out. We're going to measure our valve weights. We're going to measure, look at injector deposits and put those under a microscope even, and take a lot tighter look at what those injector deposits look like alongside of other components, and take photography.
Another part of our testing is using injector performance machines used by GB Remanufacturing. What these machines do, it'll actually measure anything from electrical impedance all the way to the flow of injectors. So what the injector is doing at idle, we can measure that flow all the way up to wide open throttle.
So as mentioned before, this is our lab scope that we actually can take the fuel injector and dial in on each individual hole in the fuel injector. A hole size in a fuel injector is roughly about the size of a ballpoint pen, so they're very small, and it gives us a good indicator of what carbon is being built up under and inside that injector.
For the next part of our testing, we will actually weigh the intake valves using a standardized procedure. So first off, we'll take the valves out of the cylinder head, and then we'll spray them down with a hexane solution just to gently wash them off. Then we'll bake them in an oven for up to 5 minutes. And after the 5 minutes, we put them in a desiccator and cool them down for 24 hours. Then we'll take those valves and we'll take them to our lab, and we'll actually weigh them on a lab certified scale, and then we'll measure every single valve in both of the cylinder heads.
It's now time to reassemble the engine and get it back on the dyno. Once it's on the dyno, we'll bring it up to operating temperature. Most of our BG products that are crankcase or poured in or done via fuel service are activated by heat. It's now time to perform our BG Platinum service. Our BG Platinum service uses our air intake valve and combustion chamber cleaner alongside with an intake adapter. The adapter attaches to the vehicle's intake, and that allows the product to be pulled in via vacuum to clean the combustion chamber and the valves. Now that our Platinum tool is installed, it's time to install our award-winning Revit tool. The BG Revit's purpose is to rev the engine every 45 seconds. The reason why that's important is to make sure that all the fluid gets burnt through the combustion chamber and out the exhaust. This allows for great consistency when performing a service. So once our service is complete, we're actually ready for our next service. Paul, can you tell us about what we're going to do next?
Of course, Jay. So the next service we're going to do is our engine performance service. It consists of 3 products, which is going to be our EPR, our Advanced Formula MOA, and our 44K Platinum. And how we do this service is we're going to add the EPR to the crankcase with the old oil. And how we perform that service is you're going to rev the engine up to 1200 RPMs, and we kept it consistent for 20 minutes. And once that 20 minutes was done, we drained all the old oil out. We did an oil change, so oil and filter. And then we added the Advanced Formula MOA to the crankcase. And then we've got the engine back up to operating temperature. The final step is the 44K Platinum. So how 44K Platinum works, it works over time in your fuel tank. So to simulate that, we ran the 20 gallons with the 44K Platinum using the AVL Plutron for over 8 hours to do a full tank fuel so we could actually monitor the full cleaning of the 44K.
So now that we've completed our services, we're going to actually do 3 more pulls on the dyno, collect that data, and then the engine's going to come completely off the dyno again, and we're going to do a full teardown. So Paul, what's it take to get one of those teardowns, and we have to do all the specific measuring, and what timeline, and kind of, can you take that through a little bit more of the process?
Yeah, so the most initial process is going to be the rigging. So that takes a long time of actually getting on the engine dyno, getting it set up, getting it run, getting those security systems disabled. So that usually takes the longest time. That can be any range from hopefully at the fast end a couple weeks all the way up to a couple months, just depending on the complexity of the engine. Next part, the tear down portion, is not too bad. I mean, my guys are pretty advanced, so they can tear it down pretty quickly, but with all the valve procedures, waiting the 24 hours, and then also taking all the pictures and having the controlled environment, it takes a little bit longer than normal to do one. So usually one project can range up from, at the fast end, 1 to 2 months. This is about normal average. It can even go up to 3 to 4 months.
So now it's time to finally talk about the results. So the first result we want to talk about is crankcase pressure. Paul, can you lead us through what that is?
But the main thing we're looking for is excessive blow-by through the ring. So as we can tell from our before and after compression measurements, which we'll get into later, but we had a 26% decrease in crankcase pressure. So how we measured that, we used an oscilloscope, which the brand we use is a picoscope, which is a great, phenomenal tool, and we measure over 1 million data points. So we have it consistently on the dyno, measuring throughout the entire length of testing. So that allows us to have more than enough data to average it out to get the correct and actual true result over the length of the testing.
So when you talk about blow-by, so the higher the pressure means the more oil that can blow past the rings?
Correct, yeah. And most modern engines are low tension rings compared to the iron rings in the older engines. So you're gonna have they're low tension rings, so they're easier to be spun. So more crankcase pressure can spin them, and cause with carbon deposits, which with the EPR corrects, that's gonna allow a more excessive blow-by.
So now let's talk about compression. What results did we find out, Paul, with compression?
Well, the results with the compression, we found that it did balance out. So it balanced out 4.8% across all the cylinders. So we can see that piston ring function improved. What you can relate back to the blow-by. So blow-by did decrease, so we can see that it did clean up. The valve, the deposits on the rings did clean up, and we restored compression and balanced it throughout all cylinders.
Okay. I assume that helps with fuel economy. That helps. What else does that help with?
Well, you want to have the cylinders all firing at the same rate. So what we talked about earlier is about not having that cylinder imbalance. Even though it's off, having a balanced cylinders because it improves in fuel economy, improves combustion efficiency, and the engine's not as working as hard depending if one cylinder's favoring another.
That makes sense. All right, great. So I think our next one was our emissions testing. Can you explain a little bit what those results were?
Yeah, correct. We had a reduction in emissions in all areas. So the gases we monitored was carbon dioxide, CO, hydrocarbons, O2, and then also lambda. So as far as lambda goes, we actually moved it closer to almost stoichiometric ratio, so 1.0, which would be pretty much near perfect. It was 1.002 as you see on the chart. And then we had a reduction in carbon monoxide and hydrocarbons, so you're putting out less pollutants throughout the entire system.
So the target for that would be 1.0.
Yeah,
we're at 1.002.
That's near. Yes, yeah, that's near perfect. The ultimate combustion efficiency is 14.7 to 1. So you want to have a stoichiometric running engine. That would be the ideal perfect condition for an engine to run at.
All right, so our next result, we're going to talk about fuel consumption. And fuel consumption, in my opinion, is one of the most important pieces, and that's what we strive for. We always want to maintain how close can we get to factory on what my fuel mileage is supposed to be. So Paul, can you tell us, hopefully we got some good results on fuel consumption?
Yes, Jay, we actually did. We had a decrease fuel mass rate or fuel consumption of 5%. So 5% is a pretty good indicator. You know, of course, today's economy of gas prices being so high, you want to have most efficiency of your fuel as possible. Another benefit by not decreasing your fuel consumption is also you can actually correlate it with CO2 output. So you're actually helping your emissions on that factor.
Oh, that's good to know. Okay. So I think rolling into our next one, let's talk about the valve weight. So valve deposits, you hear that a lot. What kind of reduction did we get a reduction in valve weight?
So since we didn't have the beginning bare weight of the valves, just the natural weight of the valve, we had to compare it before, after. So we compared what the way before and then after. And so by doing that, we averaged them all out. So the average reduction with all the valves was 0.4963 grams. So we had pretty good significant reduction of valve weight across the valves. And that's going to improve your combustion efficiency. Also prevents that carbon going down and actually falling into the intake valve, getting stuck, and then you actually have more problems.
Okay. So now we're down to our final results, which is horsepower and torque. And I know everyone always wants to know, how much more horsepower did it make? How much more torque? And you've all been waiting patiently. So Paul, what do we got on horsepower and torque?
Well, we had an increase. So we didn't have a dream killer and kill our hopes of a reduction of horsepower and torque. So we had a 13.7 gain in horsepower and a gain of 11.1 foot-pounds of torque. So we didn't just create this, we actually restored it. So we're not creating anything more than the manufacturer actually has when it came out of the factory. We're just restoring it back to those proper levels. So we're showing you by using our services or doing the Platinum System service and the engine performance service that we're able to restore engine efficiency, combustion pressure, decrease in fuel economy, crankcase pressure, all the results, even emissions. So that's a big important factor of things. So having a well-maintained vehicle is going to keep it close to the operating point through the life of the vehicle.
So those are great results. We went through and talked about everything that we've done. So if we kind of recap all this and look at everything that happened throughout the whole process. So we were able to take a 114,000 mile engine and actually perform some VG services on it and take it and put it back into a perspective of horsepower gain, fuel economy gain. We cleaned up the engine, cleaned up the piston rings, all that stuff, and brought this engine some new life. And that's what we're focused on, is bringing this, that's what we wanted to see, and we got those results. So I think, Paul, what do you, outside of that, what else would you like to add to this?
Well, I mean, you can see the benefit, as you said before, of just keeping it well maintained. So it depends on the engine, how well it's been maintained. So if your engine's been running really, not efficient for a long time, and by doing these services, we can improve that over time and have, you will have a bigger drastic result. But what you really want to do is have it maintained throughout the entire life. Because if you have it well maintained, I always say, if you have a well maintained vehicle, you're going to have less problems. So by not doing your maintenance, that's even doing your air filters, your spark plugs, anything that needs to be replaced. This just justifies or proves how well you need to have your well-maintained vehicle, and you shouldn't skip on the services or go too late. It's better to go too early than too late.
So concluding our data points here, as we just finish this up, BG strives very hard to be the best in the industry. We have our research and development from the product side to the equipment side and the service side. These are the results that, we hope we see every time. And, literally this was an engine that we pulled pretty much straight out of a junkyard with 114,000 miles on it. And you guys got to see the results. So, as we continue down this path, we do a lot of this type of research on vehicle testing. And we want to continue that and bring new information and new things to help you guys with an understanding of this is why it's so important to keep your vehicle at its top level. This is why the preventive maintenance side is good. So, if you've got other comments, you've got questions, put those down in the comment section. And, we appreciate you guys taking time, and hopefully this was informative for you.
This is just one little aspect of what we do. I mean, we have the other two dynos, like I said earlier, and we get more in depth. So we do a lot of tearing of engines apart and build them back together. So if you guys like this video, just like, comment, and let us know what you guys think.